Section 3.7, example 55, applying the comparison test. So use a comparison to show that the integral from 1 to infinity of 1 over x e to the x dx converges. So now what we want to do is find a function who is, let's see, find a function who is larger than this that converges. So if we find a function that's always larger and this ends up converging to some sort of value, this one's going to converge too because it's always going to be smaller than that. So we could find a graph that's smaller. Let's see. So I'd say just 1 over e to the x. I feel like that one's always going to be smaller. So let's do that comparison. So we have the integral from 1 to infinity, x e to the x over 1 dx. That is always going to be smaller than less than or equal to 1 to infinity of e to the x, or 1 over e to the x dx. Or you could think of it as e to the negative x. So just think of it starting at 1. Whenever we have 1, we have e to the 1. That's where it's going to be equal to. And for every value thereafter, it's going to be a little bit smaller than what we have here, especially because we're multiplying 1 over x. So 1 over x is going to give us a smaller value. So if we find that there is a value here, or it converges to a value here, we know that for sure this is going to converge to a value as well. So let's take a look at this one. Differentiating, we have negative e to the negative x evaluated from 1 to infinity, negative e to the negative, oh, sorry. Here I am jumping without actually even putting limits on here. So the limit as b approaches positive infinity of the integral from 1 to b e to the negative x dx. Limit as b approaches infinity, negative e to the negative x evaluated from 1 to b. We have negative e to the negative b minus e to the negative 1. So e to the negative b, and let's throw the limit part here. Limit as b approaches infinity, positive infinity. Doesn't matter if it's positive infinity or negative infinity. This ends up being 1 over e to the b, or 1 over e to infinity, or 1 over infinity, which this whole thing just goes to 0. So we have negative 0 minus e to the negative 1, or 1 over e. So this converges to e. So the integral from, what is it, 1 to infinity of e to the negative x dx converges to, we could say, e to the negative 1. And since the integral from 1 to infinity of 1 over x, or we could say that the function 1 over x e to the x is always less than or equal to 1 over e to the x on its interval. This tells us that the integral from 1 to infinity of 1 over x e to the x dx also converges. And there we go. So this here, actually the whole last sentence, all of this proves that we converge. And there we go. If you have any questions whatsoever, please do not hesitate to ask. Otherwise, bye.